Right, this is about 3.1 notes. So the first question talks about the function f as a periodic. With period 4, a portion of the graph is shown. Draw two additional periods of the graph on the axis above. So we can see that one period looks like this, right? Because it ends here, so obviously it makes sense that if we trace back, this is where one cycle seems to end, and we just have to replicate this thing um, uh, after that. So of course we're gonna do, just be careful that you see this axis. So it starts from 3 and okay, x coordinates are not relevant, but y will not change. So it starts from 1, intersects at 2, and then goes all the way to 3. So it starts over here, it should cross 2, which is right here, and then it should go at 3 height. Then for 1 unit it will travel horizontally, so there you go, and then it has to come down and it sort of passes right in between these 2 points at 2, so something like that, and then it goes all the way down to 1, so it's going to probably look something like this. Okay, that looks nice and cozy structure. I'm going to replicate this thing, so here 1 unit horizontal, sorry, here, there you go, 1 unit horizontal, 1 unit horizontal, and then drop down like this. Right. Here they're asking that a portion is shown what is the least possible value of the period of G. Okay, we just start from wherever you find it relevant, to be honest. I usually start from corner points. So I can start from either here or here or here. So if I start, let's say from the y-axis, so I go down, I go up, then I go flat, and that's where I stop, because that's when the cycle repeats itself. Right, that's when the cycle repeats itself. So let's count this. Starts from x equal to 0 and goes all the way to x equal to 5. So clearly the period is 5 units. Use the period of example 2 to find the values. Okay, the period is 5, right? That's what we got. The period is 5. Now I know that to find 14, see, the period means basically it repeats itself, right? So if someone asks you what is G5 and G10 and let's say G15, you're going to say it's basically the same thing, right? Because it repeats itself. G5 is same as G10 is same as G15, because in every 5 units it is repeating itself. So what your approach should be in these type of questions is you find the nearest multiple of 14, the nearest multiple of 5, the multiple of 5, sorry, which is near 14. And try not to exceed it. I mean, it depends on the question, but okay, nearest multiple of 5, which is closest to 14, is, if I don't want to exceed, it will be 10. If I want to exceed, it will be 50. So if I don't want to exceed, let's say, that's going to be 10. So 10 plus 4, this is how I'm going to write. And 10 plus 4 is irrelevant, because 10 is going to repeat itself. So I can just say that it is as simple as going to G4. And if you see over here, we already have the value of G4, right? At x equal to 4, it is actually at 7. So my answer is going to be 7 for this one. I hope that makes sense. Let's try another one. Maybe it will make even more sense. So for 72, what I'm going to do is I'm going to notice the period, which is 5. I'm going to count the table of 5 and go nearest to 72, which will definitely give me 70. So this is going to look like G of 70 plus 2. Now, G of 70 plus 2 is same as G of 2, because 70 is basically a multiple of period, which is going to repeat itself. So that's basically, overlap. G of 2 from our figure is going to be right here, which is 6. So the answer is 6. Right, so and for the last part C, I think that's a negative 17, and if we see our graph, actually, honestly, there are no negative values. Probably I can see negative 2, but not anything other than that. So if you want to write it as a negative 2 or maybe something, let's make it positive. You know what? What multiple do I want to add to make a least positive number? I think I want to add a 20 to it, because 20 comes definitely in the table of 5, and fortunately negative 17 plus 20 is 3. And what is G of 3? G of 3 is going to be, there you go, this is 3, and we have 7 right over here. So I'm going to write this as 7. Right. Here we are given that h is a period with periodic function with again 5 period. Some selected values are shown. What are the values of h of minus 2? Same strategy. I'm going to turn this into a positive number because as I can see that in the table only the positive numbers are given. So h of negative 2 is going to be same as h of negative 2 plus a period which is 5, which is going to be h of 3, and h of 3 is 0 from the table. So that's going to be my answer. All right. Here h of 6, I want to decrease this thing. So I want to write a closest number that comes in the table of 5, closest to 6, I mean. So obviously that's 5. So I can write this as 5 plus 1, which is going to be same as h of 1, and h of 1 from the table is just negative 2. H of 9, the same strategy. Don't be really confused about this composite function. H of 9. So first we'll focus on h of 9, which can be written as 5 plus 4. 5 plus 4 is just h of 4, and h of 4 from the table is given as 3. So this is same as h of 3, and h of 3 from the table is given as 0. Right, so the answer is 0. This is a pretty fancy way of saying that that this is same as h of negative 3, because if you understand, that's what we have been doing all along, right? I told you that find a table, find a number that comes in the table of the period. Here the period is 5, so table of the period, table of 5 is going to look like, any number will look like 5k, where k is an integer, which is going to repeat itself. So we can just ignore this thing, and that's going to be same as h of negative 3. I don't know what is h of negative 3, but that's totally fine. I'm going to add a period to it so that I can get it to a positive number, which is going to give me h of 2. Well, I still don't have h of 2. That's totally fine. I'm going to add another period till I find a number that is in the table. And I think if I add 5, I get 7, and yes, fortunately, I have h of 7, which is just 2. So that should be my answer. The graph of f is periodic with domain all real numbers. To find all input values of f that yield an output of 1. So the same strategy, right? First off, where is 1? 1 is right here. So this is 1 point, this is 1 point, and so on. And by the way, what is the period of this graph? If I start from here, then I think one cycle is completed over here. So I start with 1 unit, go to 5 units. So 1 to 5 is 4 units. That is the period. Now, I know that h of 2 is 1, right? But they need all such values. So don't you think I can just say that all those values will look like 2 plus 4 times k? Because if I add any number that comes in the table of the period, which is 4, it's not going to change anything. So this is going to give me all the input values. They are interested in all the input values. So basically my answer is this, because these are the input values. But make sure that you write what is k. K is an integer. And last one, I already have a video on this, so make sure to check the description for the